again. Welcome to everybody. I'm glad you could be joining us today. So what are we going to talk about? We can learn a lot from the title, quite honestly. 100 defects isn't that bad. So there's some numerics in there. So yes, we're going to be talking about measurement and metrics. And also, you know, the phrase, isn't that bad? How do we know that? How do we know whether 100 defects is good, bad, or, you know, just what's the level of quality when we discover a product that has 100 defects? So we're going to talk about not only measurement, but also having the right information to be able to make an assessment as to, let's say, the level of quality of our particular software. I usually start this talk off with, you know, some interaction with the audience, which is difficult to do today, but asking, you know, people how do they define their software quality in their shops. And typically, you know, we would get many different answers to that question. Such an absence of defects or conforming to requirements, things being scalable, reliable, talking about, a lot of times we ask people how they define quality and they talk about it in terms of testing, so kind of this these back-end quality initiatives. You know, usually when we're dealing with our clients and talking about quality, we're talking about quality throughout the full life cycle. But at the end of the day, again, what's important to us is whatever the definition of quality is within the particular organization, at the end of the day, that those measures or those definitions have to be measurable. So the question is, what are the right things to measure? And just for the fun of it, I thought rather than telling everybody what the right measures are and whatnot, I thought I'd go out on the internet and see what was available. And not surprisingly, there's just a ton of different measures that people are using to help identify their levels of quality. But what I want to talk about today is, you know, what are some of the right measures, and I'm even going to suggest that most of us on the call today participating in this webinar are actually missing a key metric that would allow us to make some determination whether 100 defects is in fact a poor quality product, or maybe it's not so bad. Of course, we don't want to have any defects, I know, but they're a fact of life, and we need to not only be able to find them, but have some measures to identify whether or not we're improving our overall levels of quality. Some of the typical measures of quality that we see with our clients and or that we recommend kind of run the full life cycle. Defect removal efficiency, something called defect density, certainly looking at test-based kinds of metrics, test cases passed for the first time. Again, and I'm going to talk a little bit later about how to properly identify the right metrics for your organization. But basically what I want to talk about today is the fact that usually there's a metric that is missing from most organizations. So let's take a look at that and see what that missing metric is, and then see how you can implement the ability or to capture the information associated with what I'm calling this missing quality metric. So let's take a look at this little puzzle here, if you will. We've got a Vice President of Store Systems Division, Mr. Smith, and he's upset. And he's upset because he has just received a dashboard with the results from the first quarter. And his #1 priority project, listed on the table below, that being Story, has the greatest number of defects. The table, and here's what was reported to Mr. Smith. So in the first quarter, we delivered, 4 projects: purchase order special project, vendor modifications, pricing, it should be pricing adjustments, and store inventory. And as it says above, store inventory, for whatever reason, was Mr. Smith's kind of pet project, the one that was most important to him, highest priority. And we can see that some of these were, most of these were delivered early or on time, so that's pretty good, including his favorite store inventory project. And we can also see what the costs are for, these are labor costs, let's assume, $500,000 all the way up to almost $1 million for store inventory. And then we see the number of defects that were discovered upon delivery. These are customer-facing defects. And you can see that the store inventory project had the largest number of defects. And this is not an unusual reporting scenario of what our management or our project teams might receive relative to information about recently delivered projects. And you can see from this information, there's some useful information or interesting information, right? The on-time delivery, that's good to know. The cost of the project, particularly if we're comparing it to some budget numbers. And quality information is important, but we really don't have, something's missing in that we really don't have a way to evaluate really whether or not, store inventory system really is what appears to be the most expensive and the project deliverable with the poorest quality. So the metric that I would want to introduce here is a sizing metric. I would want to know how big these projects were. And when I talk about big, I would want to know how big they were relative to the features and functions that were being provided to the customer. So here's that same table again, but I've added 3 columns. I've added a column about size, and a calculated rate, and a calculated defect density. And so the size, and think about this, and I'm going to expand upon this sizing metric momentarily, but for now, you can just think about this as, say, a business value metric or a measure of the amount of features and functionality that were delivered to the end user. And you can see that the store inventory project had the greatest or the biggest size or the greater number of features and functions or value being provided to the end user. And if we do a calculation, if you think of that size as a unit of work measure, let's say, and we did a calculation looking at the costs and size, we could come up with a cost per unit of work. And you could see that because of the large amount of features and functions being delivered, that the cost per unit of work was really, for store inventory project, that it was actually the most economical of the 4 projects. And if we did a defect density calculation, which you see in the last column there, which is essentially defects over size, you can see that it had the lowest defect density evaluation as well. So from the initial look-see at this list of 4 projects, we might jump to the conclusion, as Mr. Smith probably did, that even though my project was on time, it was the most expensive project delivered that quarter and had the poorest quality. But truth of the matter is, it was, yes, maybe the most expensive product, but the most economical in terms of a cost per unit of work, and it actually had the best level of quality, the highest level of quality of all of the projects.